Hey, pre-calc, we are starting 8.2 with the properties of logs, and what they're trying to do is make a connection between exponents and logs, because remember they are inverses of each other. So the whole premise is if we have the same base with different exponents, well, I mean they could be the same exponent as well, but it has to be the same base. What we do is we add the exponents. It's something we just learned. I think that's all that this box is left for. You add the exponents. Whereas in this one, if we're dividing where the bases are the same, so that might be something like b to the m power over b to the n power, that's the same as b to the m minus n. And it doesn't matter if m and n are the same, if m is larger than n, or if m is smaller than n. This rule does apply. And you can investigate on your own if you want to, or you can just believe me. That's fine. So as we move on, what that we're I guess investigating is, well, what happens if I ask you to do these two things? So if we get a calculator out and we just sort of type away of all right, I guess we don't really need a calculator. We could actually do this in our head. That we realize that log base 3 of 9 is 2, because 3 to the second power is 9. And log base 3 of 3, well, we learned that property already, that if the bases are the same, it's equal to 1. And 2 plus 1 is equal to 3. Yeah, and then the question is 3 to what power would give me 27? 3. 3 times 3 times 3. So let me highlight, so I'm trying to save you some time so you don't have to go to a calculator. That these numbers are the same, and what's unique about these values, the 3 and the 9, that gave me 27. So I'll let you ponder that for a second as I move on to the next one, where I would expect you to be able to do this in your head, that 2 to the third power gives you 8. Same thing here is 2 to the second power gives you 4, and we're adding in between those. I guess I didn't emphasize the adding in between. 3 plus 2 is equal to 5. Well, if I ask the same question here, 2 to the fifth power gives me 32. So again, let me highlight what you're supposed to recognize, that this number is the same as this, and what operation can you do between 4 and 8 to get to 32? And if your answer is multiplying, then you're absolutely correct. So if you're adding two separate logs, we can combine them by using multiplication. That's kind of what we're getting at here. Log base b of m plus log base b of n is equal to log base b of the quantity of m times n. So in other words, if we're adding two logs with the same base, then we multiply. I'm going to use the phrase arguments. Now here's the thing, is we could also work backwards. Okay, if we had a product in here and we want to separate them into a combination, sometimes we call it expand. If we want to expand a logarithm, we could go backwards as well. Let me use a different color. We could go this way, which is what we are investigating up here, or we can go backwards. So let's see if that's also true for natural log. Well, it should be. If I'm going to write it down as a rule, it should be true. You see how we have 3 and 2, we're adding, and 3 times 2 is 6. So let's investigate. Natural log of 3 plus natural log of 2 gives me a pretty ugly number, and my conjecture is natural log of 6, because 3 times 2 is 6, is the same nasty number, 1.792. 1.792. So the whole idea is if we're adding in between these, we can combine it into a single logarithm using multiplication, and that is exactly true. So let me go back a little bit, because when we were multiplying, we added exponents. When we are dividing, we subtracted. Where did my m go there? I don't know if I ever wrote it. So what I'm trying to get at then is maybe you're already making a premise as to what will happen for these two things, because now we're subtracting between the two. Well, we've already seen 2 to the 5th power is 32, and 2 to the 2nd power gives me 4, and then the subtraction is there. 5 minus 2 is 3. Well, what's 2 to the 3rd power? It's 8. Log base 2 of 8 equals 3. So maybe I'll even use a different color highlighter just to kind of change it up. We got 3, 3. Well, what can I do between 32 and 4 to get 8? I hope you're thinking that we need to divide. Divide, if I can spell correctly. That was an I. 32 divided by 4 is 8. Let's see if that's also true with the next one. 3 to the 4th power gives me 81. 3 squared gives me 9. If I'm subtracting those two numbers, I get an answer of 2, subtraction. Is it true that 3 to the 2nd power is 9? And what's happening between 81 and 9 to get 9? Your answer should be that we divide. So is that always true? I guess I didn't finish this one either. Finish that and get some good notes. A times B. Is if we are subtracting here, notice the difference, we're subtracting, then, and the bases are the same, then we can divide our arguments. So if we're subtracting 2 logs, notice that I have to say it has to be the same base. As if we have different bases, we cannot do that. Then we divide those arguments. And again, just like before, we could expand. We could go the other way as well. Now let's see if it's also true for natural log. Let's investigate real quick. It's not too difficult. See how we have 12, natural log of 12 minus natural log of 3, and 12 divided by 3 is 4. Well, let's use a calculator, because I do not expect you to know natural log of 12 in your head. Okay, that's an ugly number. Is it true that natural log of 4 gives me the same number? If you're confused where 4 comes from, that's because 12 divided by 3 is 4. Well, I got 1.386, the same ugly decimal. 1.386. And it worked because of the division. So yes, this is still true. This is an important rule in calculus. So even if you learn this in Algebra 2, strongly recommend really diving deep in this, because this will help you in calculus. That's why we do this in pre-calc. So there's one more rule we need to investigate, and that is this one. I don't really like that we can't do these problems in our head. We actually need a calculator. But I usually don't even teach this using investigations like this. So I might even just show you the answer key, because usually what I do with students is I do any base, log base b of, I don't know, I'll just stick with m squared. Because what we just learned is that we could rewrite that problem as log base b of m times m. Well, we just learned that if we're multiplying, we can separate them into 2 separate logs, log base b of m plus log base b of m, right? That was on the previous slide. Well, how many log base b's of m's do I have? I have 2 log base b of m. So what I'm trying to get you to, I guess, investigate, even though I didn't really write it down here, is that where did this 2 go when I simplified it? It went out front. So sometimes you see me just write, like, it seems like magic, but there's a math behind it, that this exponent will go in front and it turns into multiplication. So hopefully this makes sense, and I hope you realize that you could do this to any exponent. You know, if this was m to the 3rd power, we would just have 3 m's here, which means we would have 3 log base b of m's. You can do it to the 4th power, to the 5th power. We can do it with fraction exponents, although Fractions are a little bit more complicated, so you're just going to have to trust that that's true. And I'm just going to, let me just show you the answer key. So go ahead and type these into your calculator and see. And if you're confused, you might need to use parentheses on this first one, or you could just change it to 25. But you get the same exact answer for any of these problems. And so what's the pattern? Is if you have log base b of a to the n power, again, any of these variables can be different, it doesn't really matter, it's equal to moving that exponent in front, and it turns into multiplication. So instead of me writing this, I just decided that you could hit pause in the video and write it down, and you could actually get a more mathematical statement instead of my bullet points. So anyway, the exponent of the argument of a logarithm, and it doesn't matter what the base is, the base can be anything, can be rewritten as the coefficient of the logarithm and vice versa. So that was me talking about that we can go both ways. So you might have a problem with a power that you need to move in front, but you might also have a coefficient that you need to rewrite as a power. So go ahead and hit pause as I jump back to the notes. So let's just get a few practice problems in, and I hope you're okay that you need all three rules, because here we're adding, here we're subtracting, and notice that there's no coefficient here. So all I can do with this problem is multiply 6 times 8/3. Now I do actually want you to simplify that. For instance, 3 goes into 6 twice. So we're looking at log base 2 of 16. And I would expect you to know that 2 times 2 is 4, times 2 is 8, times 2 is 16. That was 4 2's. And I expect you to be able to do this without a calculator. So be ready if we get a chance to having no calculator test, that this could be on there. So let me just, I think that made perfect sense. If you don't like how I did this, you could have done 6 times 8 is 48. Divided by 3 is 16, and then get the correct answer. So on the next one, I do want you to start and go slowly. There's no rush here. Log base 3 of x to the 1/3 power minus log base 3 of y squared. That's applying that third rule that was up here. But we also have this subtraction in here. So to combine subtraction, you use division. And just one more thing, I would really appreciate it if you got rid of the rational exponent and rewrote this as the cube root of x over y squared. But depending on the directions, or if it's multiple choice, you might get an answer, and that would be acceptable, or this would be acceptable. But I want you to practice both ways right now. So here's another problem where, well, now we have a combination of things. But for me, it makes perfect sense. Anywhere that you're adding, just do exactly after it. The very next one, whoops, do not write natural log twice, is turning into multiplication. So x plus 2 times x, and then here's your subtraction. So the one exactly following it is going to turn into dividing by x cubed. Now, as far as simplifying this, I would like you to simplify it because you can cancel out one of those x's. So we're looking at x plus 2 over x squared. Now, the reason why I talk about exactly following is because I've had students in the past kind of get this wrong. If you have a problem like log, I'll just leave it as log, of, I don't know, 1,000 minus log of 10 plus log of 100. I've had students do this incorrectly, where this log, so if we combine it as 1, this 10 goes in the denominator because it's exactly following a minus, so that one's divided, but this one goes into the numerator. So I don't expect you to finish that problem, but I'll see you in the next video to finish these notes.